Hello, everybody. Welcome to the second day of the fourth edition of NASA Space Apps Challenge 2023 UAE and Muscat. Hope you are doing well and working on your project. Today we will have some technical sessions. We will try to go with your process. I just want to inform you that today is the deadline. The deadline of submission your idea is at 12 midnight. You should submit your idea correctly so you can be nominated to the global judging. Our judging panel will be tomorrow after 4 p.m. You will receive your panel time or your panel slot by email today after the deadline of the submission. Dr. Lucas will join us in a few minutes. He gonna speak with you about your challenge. For all of you, if you have any technical or general question about the challenge, we encourage you to join the Space Apps Connect, especially GitHub, to ask your question or to contact with the mentors or the global teams. You can participate or access the Space Apps Connect from your profile on the NASA Space Apps website. Also, we are with you today. If you have any question regarding to idea submission, you can reach us via Space Connect or via mail. We will answer your question and we will help you to submit your idea correctly. Hello, everybody. Now I'm gonna show you a video to how to join Space Apps Connect to ask your question, even it's a technical question or general question.
لا شيتوس ليه؟ حد كان بيتكلم؟
Space Apps Connect, formerly known as Space Apps. Space Apps Connect is a platform where participants can ask questions and interact with the Space Apps community, which is made up of local leads, navigators, SMEs, global collaborators, the NASA Space Apps Global Organizing Team, or GO team, and other participants. This year, we're excited to announce that Space Apps Connect will be conducted on GitHub discussions. You can find our Space Apps Connect guide on the Space Apps website under resources in the main menu. This guide has instructions around conduct and etiquette within the Space Apps Connect platform and will tell you everything you need to know to have the best experience possible. Now let's head over to GitHub to get you started on your Space Apps Connect journey. First, let's go over how to sign up for an account if you don't already have a username and password. First, navigate to github.com to the homepage and find the sign up button in the upper right-hand corner. Next, use the email you wish to use for Space Apps Connect. Then enter in a password. Next, you'll want to create a unique username. Then be sure to write Y for yes or N for no if you'd like to receive product updates. Then you'll be asked to solve a CAPTCHA puzzle to verify your account. Then you'll want to click Create Account. You will be sent an email with a verification code. Be sure to paste that here. And you're in GitHub. You can skip the personalization and you'll be brought to your new homepage. Once you've verified your email, be sure to change the notification settings to whatever best suits you. You'll do that by clicking your avatar, going to Settings, and then clicking on Notifications. You can change your notifications here and here. Then, if you'd like to keep your email private within the Space Apps Connect platform, navigate to the Email section. In order to keep your email private, be sure to scroll down and make sure the checkbox that says Keep my email address private is checked. This will keep your email private at all times while using GitHub. Now you're ready to get started with Space Apps Connect. Now it's time to navigate to the Space Apps repository. You'll go up to the search bar and type in NASA/Space Apps and click Enter. Then it should be the first thing that pops up in the results. Now that you're here in the Space Apps repository, Be sure to star this repository to be able to bookmark it. In different scenarios, GitHub is a platform that is used to commit computer code to a project. A repository is a page where normally you'd be able to save your project's code and see any revision history within your project, but we won't be committing any code today. This repository or homepage for your project is where you can access discussions. Here, you'll see the Space Apps repository. Make your way to the Discussions tab at the top, and voila, you've made it to Space Apps Connect. Be sure to bookmark this page for easy access later. The list on the left are all the discussion categories you will have access to, so let's go over them. First, we have Welcome. Say hello to the Space Apps community in this category. Next, we have Announcements. The NASA Space Apps Global Organizing, or GO team, will be using this category to provide you with updates, so be sure to check it frequently. The GO team plans and implements the NASA Space Apps Challenge each year. This team is dedicated to guiding and supporting participants through a successful NASA Space Apps Challenge journey in Space Apps Connect and beyond. In this announcements category, you will find information about the hackathon, reminders, words of encouragement, and notices about the system and any troubleshooting that is needed. Next, we have the challenges category. Ask questions about the challenge you're working on. Be sure to include the challenge name in the start of your discussion. Then we have Find a Team. In this category, you can talk with others and find teammates to tackle a challenge. Then we have General. Post about anything and everything related to Space Apps here. Next is Global Offers. Ask questions about global offers here. Global offers are free tools and resources that are optional to use when creating your project. In your discussion title, please be sure to include the global offer you are asking about. Next, we have languages. Talk to other participants in languages other than English in this category. Then we have local events. Here you can find your local events discussion. Not all local events will be using GitHub discussions. If you do not see your local event in this category, please check your local event page on the Space Apps Challenge website at spaceappschallenge.org for information on how to best contact your local lead. Then we have the project submission category. You can ask any questions you have about the project submission process in this place. And then finally, we have random. Feel free to post and talk about anything that does not violate the Space Apps or GitHub Code of Conduct. Before creating a new discussion, it's important to make sure that there is not already an existing discussion that asks the same question that you are. To begin your search for discussions, click on the View All Discussions button to be able to see every discussion that's available. In order to filter, you can click on the Filter button and select All. By selecting All, this allows you to show all discussions regardless of their status. Next, you can select a label. There are labels for all sorts of things, including challenges. So I'm going to click Artemis 2 and U, a challenge. This will show me all the discussions that have been labeled with this label. So you'll see that Artemis 2 and U is located on both of these discussions here. You can also see that the label has been added to the filter search bar. If you'd like to get rid of this filter, you can either delete it from this search bar or go back to the label filter and deselect the filter you selected. Another way you can filter is by using the filter search bar. By default, you can see here that it says we are filtering by all discussions that are open. You can manually type in this bar to add filters yourself. So if I wanted to see any discussions where the word help is mentioned, I would simply type in help and click enter. This now shows me all the discussions where the word help has been mentioned. Please keep in mind that when you add multiple filters in one search, the results will only show discussions that match all the filters together. You can also search through discussions by using this sorter that allows us to search by different conditions. By default, we're searching by latest activity. So whatever discussions had the most recent activity will appear at the top of the discussion board. You can see that you're able to sort by different things here too. Date created shows us the most recent discussions that were created, and top all shows us the top discussions by upvotes, which we'll talk about later in this video. Lastly, we can filter discussions based on their status. So if we wanted to see all the discussions that were unanswered, we would select unanswered. So now we are currently looking at all discussions that are open, where help is mentioned and is also unanswered. And these are the results that we get. So as you can see, there are many ways to search for what you're looking for within Space Apps Connect. Remember, before posting a new discussion, to search throughout the discussion boards to make sure that your question hasn't already been asked. Now, speaking of new discussions, let's go over how to post a discussion within any category in Space Apps Connect. Once you have determined what category your post should go in and you have made sure your question has not been asked before, you can go ahead and select your category. Please note that you must be signed into GitHub to interact with the Space Apps community, so be sure to see if you see an avatar in the upper right-hand corner. For the sake of this demo, I'm going to post in the challenges category, so I'll select it by clicking on it. Next, I'll select New Discussion. I'll give it a discussion title, and then I'll be sure to ask my question. When I'm done, I will make sure that I select the button that says that I have done a search for similar discussions, and I will click Start Discussion. You'll see that my discussion has appeared here now. If I go back to our discussion page and click Challenges, you'll see that my most recent discussion is now first in line since we are sorting by latest activity. When writing in the body of your post, make sure that the content stays within the category you're writing in. When writing your post, make sure that it doesn't ask questions that are outside the scope of this category. So for example, if you're writing in the challenge categories like me, don't ask questions about local events or project submission, as they have their own categories here. You can comment on a post by clicking on the post you'd like to comment on, then scrolling down and writing your comment. Then to submit your comment, you'd click the comment button. Now you can see my new comment is here. If you decide you no longer want your comment there, you can click the three dots and simply click Delete to remove your comment. If you'd like to reference another discussion within your comment, you can click on the word bubble icon here. Then you'll type in the title of the discussion you're wishing to reference. So we'll try to reference the one that I created before, Help with Artemis 2 and You. This is a reference. Now, when I comment, you'll see that the number turns into a link and it will go straight to the other discussion that I have created called Help with Artemis 2 and You. If you'd like to mention another user in your discussion, you can use the @ symbol followed by the username. So if I'd like to tag Chris from the Go team, I would simply do that, click his name, and then write my comment. Then I would click comment, and Chris would be tagged in this comment. Please remember to be courteous and refrain from spamming usernames. You can close your discussion when it has been resolved, is no longer relevant, or is a duplicate. This reduces the number of discussions present in the active section of the GitHub discussions page. To close your discussions, click on your post and scroll down to the comment section. You can either click on Close Discussion here, or the drop-down, which will have you select a reason for why you're closing it. Then you'll click Close Discussion. Now this discussion is closed. Now let's navigate back to our discussions homepage. We'll click on Challenges again and click on another comment. This button here is an upvote. If you have a question and another participant has already asked that question, but it is yet to be answered, you can upvote a discussion topic in order to get it more visibility. Additionally, if you just happen to like a post or comment, feel free to upvote that too. So you can upvote this one here and a comment too by clicking both of those buttons. Remember, Space Apps Connect is a place for you to go as a participant to have your questions about the hackathon answered by a member of the larger Space Apps community. Whether you are interacting with a Space Apps navigator, SME, local lead, Go team member, or another participant, we encourage you to meet someone new and most importantly, have fun. NASA Space Apps is committed to providing a professional and productive forum for all participants to engage in a robust exchange of ideas. We strive to ensure that NASA Space Apps is a place where every person feels like they belong, where they are comfortable being authentic, and where they feel empowered to contribute to their fullest. If you experience or witness discrimination, harassment, or bullying during the NASA Space Apps Challenge or within Space Apps Connect, please navigate to your local event page to determine the best way to contact your local lead or email the global organizing team at conduct@spaceappschallenge.org. Follow us on Twitter, Facebook, Instagram, and YouTube to help stay up to date with the latest updates.
Hello, my name is John Walton, and I'm the Earth Public Engagement Lead here at NASA's Jet Propulsion Laboratory in Southern California. Did you know that we're running out of fresh water? Earth has 370 quintillion gallons of water, but only about 0.01% of that is fresh water that we can use. As climate change alters the global water cycle, this precious resource is in danger of becoming even more scarce. Already, roughly half of the world's population is experiencing severe water scarcity for at least part of the year. Warming global temperatures threaten to reduce freshwater availability even further, which could impact critical areas like drinking water, agriculture, and more. Your challenge is to help young students better understand how climate change will impact freshwater availability using new data from the Surface Water and Ocean Topography Mission, or SWOT. SWOT is performing the first global survey of fresh water and will take a snapshot of global resources every 21 days to help track changes in freshwater availability over time. Understanding how freshwater resources are changing will help communities make better decisions about how to protect this vital resource. From the global down to the local perspective, SWOT high-resolution data can help tell the story like never before and give students clear evidence of the ways climate change is impacting our world. Whether you use a single visualization or create a series of infographics based on mission data, or something even more creative, there are many ways to tell this story. These stories should be simple, straightforward, and connected to the larger story about how climate change is affecting the water cycle. Importantly, keep in mind your primary audience of K-12 students. Focus on compelling storytelling through data visualizations. You may also want to show how human drivers like agriculture and industry are impacting freshwater resources in addition to climate change. And as always, interactivity is a bonus. Thanks for your attention, and good luck.
All right. Here now.
Hello, I'm Audrey Talamante from Arizona State University, and I'm a program coordinator with the NASA Psyche Mission Student Collaborations Program. I'm here to invite you to plan a party to celebrate NASA's journey to a metal world. The NASA Psyche mission is an exciting orbiter mission that will explore the Psyche asteroid in the asteroid belt between Mars and Jupiter. This asteroid is of great scientific interest because it is likely rich in metal. It may consist largely of metal from the core of a planetesimal, which is one of the building blocks of our solar system. The Psyche mission will explore, for the first time ever, a world made not of rock or ice, but of metal. Members of the Psyche mission team come from all around the world and from various backgrounds, but they are all united in their love of space exploration and creativity. In fact, many of them are artists, musicians, and crafters themselves. Big ideas, like exploring an asteroid, often have their roots in creative play. Teachers, museums, libraries worldwide use crafts, costumes, games, and more to encourage children and lifelong learners to engage with the world around them and to explore the current and future possibilities in their own lives. While space exploration can feel unattainable or can be difficult to understand, crafting and play can remove barriers and enable everyone to feel included in the adventure. Your challenge is to create an original Psyche-themed party package, for example, invitations, decorations, costumes, crafts, games, art projects, and more, that engages learners of all ages in hands-on, creative, and crafty play and allows everyone to participate in the excitement of exploration. You can use information from the Psyche mission, such as mission goals, timelines, science, objectives, technology, teamwork, Psyche-inspired art, and more to inspire a celebration that can help everyone around the world get involved. We can't wait to have you use your creativity to join us on our journey to a metal world.
There aren't many classes of objects left in our solar system that we haven't looked at up close with a spacecraft. And one of them that's left is the metal asteroids.
16 Psyche is an asteroid that orbits the sun out between Mars and Jupiter.
The reason that Psyche is unique is that it is metal rich. It's believed that it may be a remnant core of an early planetesimal that was formed in the very, very earliest parts of the formation of the solar system.
And after this planet started forming and this metal core formed inside of that, it collided with other bodies that then stripped off the rocky mantle, leaving this core in place.
This is the part of planets that we can't sample directly today.
It's too hot, the pressure's too high, our instruments would melt. Can't drill a hole that deep in the Earth or other planets. So how do we study the core of our planet?
Psyche gives us the opportunity to visit a core, the only way that humankind can ever do, and it would be the first metal object that humankind has ever visited.
After launch, we cruise through interplanetary space for a number of years. First, we fly by Mars for gravity assist that'll slingshot us into the asteroid belt. And then we're thrusting all the way from there to finally arriving at Psyche.
We'll go into 4 orbits to collect the necessary measurements that we need from our 3 primary instruments.
So our payload consists of a couple of imagers, which are cameras that take pictures of Psyche. Also a gamma ray neutron spectrometer, which allows us to measure the elemental composition of the surface of Psyche. And then a magnetometer, which will allow us to detect any magnetic field that's left at Psyche.
If Psyche still has some sort of remnant magnetic field, that probably tells us it really was a core. It's a strong indicator. We also use the radio on the spacecraft as an instrument, so we can map out the gravity and map out the interior structure that way.
We're using a particular thruster technology, Hall effect thruster technology. They operate 5 times more efficiently than normal rockets, so they use a lot less fuel, and is what allows us to get into orbit around this asteroid.
Solar electric propulsion has been around for quite a while, and it has flown before, but we're continuing to push the boundaries. We're going to have big 5-panel fold-out solar panels that will provide the electricity for the thrusters, which use as propellant the noble gas xenon.
This will be the first time that Hall effect thrusters have flown in deep space.
Studying the evolution of a planetary body is a detective story.
There's a magic to when you actually are on the launch pad and you say, we're go for launch.
And you feel like singing and dancing and you feel like throwing up at the same time.
Let's go discover things about our solar system that we have no other way to do. I think that it's fundamental to who we are and also who we should be. It's an incredible opportunity to be a part of the team making that happen.
Hello, we work on NASA's Fire Information for Resource Management System, or FIRMS, and we're excited to introduce ourselves and tell you about our Space Apps Challenge. It's called Managing Fire, Increasing Community-Based Fire Management Opportunities. My name's Diane Davis, and I'm the FIRMS Project Manager.
My name is Otmar Olshina. I'm the Senior Software Developer for FIRMS, which means I keep the system running.
I'm Asen Radov, and I'm a software engineer for FIRMS, which means I work very closely with Otmar to make updates and enhancements to the system.
I am Jenny Houston, and I am the Implementation and Outreach Manager for FIRMS.
I'm Brad Quayle, and I work for the USDA Forest Service. I'm a partner on FIRMS, and I provide lots of user perspectives and guidance on the system.
Our challenge is very interesting because we want you to help make sure everyone can use the wildfire data that is in FIRMS. Many different community groups and governments and citizens and companies and journalists and newspapers are starting to use the data in FIRMS. We want you to design and develop even more solutions so that even more people can use the wildfire data, contribute to collecting data on wildfires, and help reduce wildfires. Over to you, Brad.
Thanks, Otmar. Well, when it comes to wildfires, the time is now. Every day, the number and size of wildfires around the world is increasing, and we need more people to be able to use data to help combat wildfires. Wildfires can destroy neighborhoods, cause terrible air quality, impact wild animals and their habitat, increase the potential for soil erosion and landslides, contaminate water supplies, and increase greenhouse gas emissions. These are all very negative, and they often impact local communities the most within or near forest and other undeveloped areas. And over to you now, Austin.
Thanks, Brad. So why should you participate in our challenge? Because you have the opportunity to actually help design solutions. And you can think outside of the box. How exciting! Maybe you design a smartphone app that can be used to add information about the wildfire. The size of the wildfire, the amount of the damage, the types of the trees burned. Or what about a tool that alerts communities about water contamination because of soil erosion after a wildfire? Your solution will help communities monitor and manage forests.
Thanks, Asan. Wow. I bet you're excited to begin. Now, your solution can be technical or non-technical. There are so many options. Don't forget, communities might be rural and they might be isolated. So your solution needs to be easy to understand and use, and your solution needs to work where there is cell reception, but also where there is no cell reception. You could think about drones, or what about local radio stations? Maybe you want to use machine learning or artificial intelligence in your solution. You decide. We are counting on you.
Tired of those long trips to the post office? Don't want to spend a fortune on sending a parcel? Then it's
Welcome to the NASA Space Apps Challenge. Today, we present to you an exciting opportunity to push the boundaries of space weather forecasting. Join us as we dive into the depths of space to develop the Oracle of Discover, the Space Weather AI ML Severity Predictor. Geomagnetic storms are a menace to modern technologies like GPS satellites and power grids. These storms are caused when solar wind gusts from the sun interact with Earth's magnetic field, resulting in potential disruptions to our critical systems. To tackle this challenge, we utilize the Discover spacecraft, located approximately 1.5 million kilometers upstream of the Earth. Discover measures the plasma that may cause geomagnetic storms, ideally providing us an early warning of incoming space weather. But here's the twist. Discover's aging sensors introduce faults and anomalies into the data. These anomalies might just hold the key to predicting geomagnetic storms. Your mission is to build a system that takes the raw data from Discover, including the anomalies, and predict geomagnetic activity levels. Instead of relying on stable, well-calibrated data, you'll use machine learning regression, or any method you choose really, to make accurate predictions despite the noise. So dive into the data, explore the anomalies, and design an innovative solution that transcends traditional approaches. Are you ready to embark on this thrilling Space Apps Challenge? Build the Oracle of Discover and revolutionize space weather forecasting. Together, we can protect our technologies and weather the storm through the solar maximum.
Hi, I'm Kelsey Bisson, and I'm the program scientist for NASA's Ocean Biology and Biogeochemistry program. I'm introducing the challenge, What's Up with This Water? Have you ever been swimming in a natural body of water and felt curious about the microscopic and larger life around you, or what else has been living in the water? We know that there's a vast amount of life in oceans, rivers, and lakes, most of which cannot be seen with our own eyes. Your challenge is to create an app that notifies people of endangered species in the bodies of water around them with information about what people can do to help preserve these species and use the water for recreation in the most respectful way. We all check weather apps, sometimes every day, to learn how we can go dress in the world and prepare ourselves for what's to come. Much less attention is paid to our water systems. There are a number of reasons to learn more about your local water ecosystem, particularly practical logistical concerns with water quality, ethical concerns with endangered species and also with water quality when it comes to drinking water and who it has access to clean drinking water, and scientific curiosities, including where the water mass was prior to swimming in it, for example, if you're in the ocean, as well as what's living in the water in terms of interesting creatures that are inspirational in their own ways. People need to know if water is safe before they go swimming. And ideally, they can also learn about the endangered species in the water and how that we can best support our ecosystem. There's additional knowledge in other curiosities, for example, learning where the water has been through ocean circulation in the days, weeks, and months before swimming in it. And we envision a future ultimately where people can check a water weather app to learn the conditions of their local bodies of water, as well as how they can support continued water health while they're there. So your challenge is to create an app for users that allows them to check the water quality of their waterway. And in addition, features of the app would be, for example, check what local endangered species are living in the water, as well as how to protect them, as well as perhaps where the water has been in a circulatory sense. If, for example, you can imagine you're swimming in North Carolina, that water mass that you're swimming in was likely previously in the south in the Gulf of Mexico, and then came up through the Gulf Stream. The app is meant to be very similar to a weather app, but much more simplistic. We really stress that participants who are interested in this challenge think about what they would find most interesting when using a water weather app and what sort of additional features they would find most useful, playful, and inspiring.
If you want to make money online as an affiliate marketer, you may find this a little bit controversial, but we've stumbled across a way to earn reliable.
Hi, I'm Kelsey Besson, and I'm a program scientist for NASA's Ocean Biology and Biogeochemistry program. I'm introducing the challenge Ocean Gardens. Imagine you visit a landlocked region where none of its inhabitants have ever been to the ocean. Yet every single day they've been alive, we know they breathe oxygen generated by marine photosynthesis, benefit from the lower carbon dioxide in the atmosphere, and consume food that was fueled by marine ecosystems. Your challenge here is to create a platform that visually, sonically, and interactively connects the services the ocean provides to anyone that visits the platform in a way that they can best understand. For background, the ocean makes up 70% of Earth by area and up to 95% of the volume habitable for life on Earth. Half of all of the new biomass on Earth in terms of rates is from marine phytoplankton, which are unicellular plant-like organisms that perform photosynthesis. These phytoplankton form the base of the entire ocean ecosystem, and they not only provide food for other animals in the sea, but they also absorb carbon dioxide and provide a link for carbon sequestration. There are big gaps in ocean literacy in the United States, and many people do not recognize the giant role the ocean plays in our everyday lives. We are faced with pretty big challenges. Limiting global warming to 1.5 degrees Celsius would require carbon dioxide removal on the order of 100 to 1,000 gigatons carbon dioxide in the next century. And I almost said insurmountable, but they're not insurmountable because we are equipped with very creative minds, and that level of effort will surely create a better future. We know that the food and energy insecurity have been exacerbated by climate change, conflict, and disease, with global energy demands only expected to grow. Ocean solutions, including deep seabed mining, have been suggested as ways to support shifting to renewable energy and increasing food supply. Industries have begun exploratory extractive activities, and meanwhile, our scientific understanding of these impacts on the activities is trailing behind. There is a sense of urgency to educate voters on the role the ocean plays in their life so that they can make informed decisions about future policies. We know science is a primary avenue by which the public and lawmakers understand and value ocean ecosystems. So how can we make science more accessible and translatable to others? Here, the overall goal of the challenge is to convey the ocean's importance to people in ways that they can best understand. For example, one could view the ocean as a garden where phytoplankton are growing at different rates similar to vegetables on land. Basically, through a combination of techniques, could be visual, sound, software, video, or even cartoons and comedy, participants will create a platform that will introduce the ocean and its services to people who are assumed to have very little prior knowledge. We support a platform of any variety that is most suited to the goals that the participants see with this challenge, including a website, an app, a YouTube video, performance, coloring book, etc. We really look forward to seeing your submissions.
The sun touches everything, and this year we're hosting a global celebration of solar science and the sun's influence on Earth and the entire solar system called Helio Big Year. The Helio Big Year, also known as HBY, runs from October 2023 through December 2024. It includes 2 major solar eclipses over the Americas, the sun's solar maximum, when sunspots are the most numerous and solar flares are more common, and the closest approach to the sun of NASA's heliophysics flagship mission, the Parker Solar Probe. Millions of people are expected to take part in HBY activities, and we need your help. Hi, my name is Priscilla Foreman, a NASA intern working with the HBY team, and here are a couple ideas to help you tackle this year's challenge. How can you leverage upcoming celestial events happening during HBY to solve this challenge? Can you help HBY go viral? Maybe by sharing inclusive locations for event viewing and other information in your part of the globe, at your school, or with another specialized audience. Maybe you can build an app that identifies people who might want to participate in a heliophysics citizen scientist project based on their social media likes and interests. Or maybe create a social feed that helps interested participants find a project suitable for their location. How can your solution incentivize participation in HBY and heliophysics citizen science projects? Or maybe create a mashup between a job search platform that identifies people with needed skills and a social media site that connects people with shared projects. Remember, the sun touches everything, and we need your help to reach everyone. We can't wait to see what you create and help us promote this year's heliophysics Big Year.
Hello, I'm Charles Nichols from the NASA Metallurgy and Non-Destructive Testing Lab at White Sands Test Facility in New Mexico. And today I'm thrilled to present the STAR Challenge, an adventure into the frontier of technology, creativity, and innovation. At the heart of our space missions lies an intricate web of technical requirements, a complex maze that ensures our journeys are safe, efficient, and successful. In the STAR Challenge, it's all about you embarking on a mission of your own, creating an AI-powered tool that could streamline the review process of these vital technical requirements. Now, let me make this a bit more tangible. Imagine an AI that can ingest NASA's vast databases, sift through the complexity, and provide effective recommendations for improving these requirement documents. That sounds pretty incredible, right? But here's the catch. We're challenging you to eliminate what's known in the AI world as hallucinations. These are the errors or inconsistencies that can occur in AI-driven processes. Your solution must be free from these hallucinations, ensuring that our missions are guided by the most accurate and reliable suggestions possible. What makes this challenge truly fascinating is its relevance in today's hyper-connected, data-driven world. We're not just looking for an AI tool, we're looking for a tool or process that can protect nationally sensitive information governed by international traffic and arms regulations and export administration regulations. This is an essential layer of complexity, a challenge that requires creativity and precision. Why is this vital in today's world? Well, we live in an era where information flows at the speed of light, and the integrity and security of that information are paramount. Your solution must not only be efficient and accurate, but must also guard against unauthorized access to proprietary and nationally sensitive information. It's a dance of technology, responsibility, innovation, and integrity. Why should you accept this challenge? Well, simply put, this is your chance to contribute to something that is greater than yourself. The STAR Challenge is not just a competition, it's a call to action. It's a chance to apply your skills, your creativity, your vision to a challenge that's at the very core of our journey into space and in many other regards throughout industry. You could be the one who helps us take the next giant leap and helps us fix something that could save a life. Whether you're a coder, a space enthusiast, or creative thinker, we invite you to embark on this unique journey. The STAR Challenge isn't just about winning, it's about pushing boundaries, about forging a path where none existed. It's about using technology to ensure the safe and efficient journey of our astronauts in space. So, are you ready to accept the challenge? Are you ready to create an AI tool that's free from hallucinations, that protects the essence of our missions and that could change the way we explore the cosmos. Join us on this thrilling adventure and let's redefine the future together at Astra. Thank you for your time, and may creativity and innovation guide you in the Star Challenge.
Do you know what's hiding in your business's data? Companies of all sizes use BigQuery to uncover new insights from their data.
Hello again and welcome back. I'm Charles Nichols from NASA's Metallurgy and Non-Destructive Testing Lab at the White Sands Test Facility in New Mexico. Today we're going to journey into the heart of the Star Challenge and explore the exciting opportunities and complex scientific layers it holds. The essence of the Star Challenge is to develop an AI-powered tool to streamline the review process of our technical requirements. These are complex documents that lay the foundation for our missions, dictating everything from spacecraft design to operational protocols. They're crucial to the safety and success of our space expeditions. Our goal with the Star Challenge is to revolutionize the way technical requirements are managed within the aerospace industry. We're seeking an innovative process or tool that can assist us in assuring the accuracy, consistency, and relevancy of these vital documents, which are so crucial to the safety, reliability, and success of our missions. Now, you might be thinking, Charles, that's a massive task. And you know what, you're right. But here's where it gets exciting. A tool like this has the potential to revolutionize the safety and efficiency of processes across a multitude of industries. And it could rapidly improve the world around all of us. The task at hand isn't just about creating an AI tool or process. It's about designing an intelligent system capable of digesting vast amounts of information, identifying critical insights and/or oversights, and providing effective recommendations. Imagine it as creating a super intelligent advisor, one that could guide us towards more accurate and consistent technical requirements. This would lead to safer and more reliable missions for us. This system should be designed to avoid hallucinations, which are inaccuracies in AI's interpretation or prediction, and handle data with the utmost care, respecting all rules and regulations regarding sensitive information. This challenge isn't just technical, it also involves ethical dimensions as well, with the responsibility to handle nationally sensitive ITAR and EAR data with the necessary care. But don't worry, in this situation, you're not going to have access to any of that information. We'll just give you the publicly available sources. Now, let's dive into the science behind this. The STAR Challenge is rooted in the field of AI, particularly natural language processing, NLP, and machine learning. NLP is the science of enabling machines to understand and generate human language. Machine learning, on the other hand, is about training machines to learn from data to improve their performance over time without being explicitly programmed to do so. Your task is to use these technologies to develop an AI tool or process that can analyze technical requirements, identify the inconsistencies, errors, and omissions, and provide effective recommendations to improve these documents. This involves significant technical skill and understanding, and it requires a knowledge of AI, NLP, machine learning, data science, and some cybersecurity. Now let's get into the specifics of the challenge. Your tool can analyze and suggest improvements to NASA Standard 5009. This will serve as the test bed, giving you a real-life scenario to experiment with and perfect your solution. On my end, our NASA experts have completed a thorough review of NASA Standard 5009 and have yet to release the latest version to the public. We will evaluate the effectiveness of your solution by comparing its suggestions to the updates that we've made in the standard. Getting excited yet? Your recommendations should include the section number and version letter of the document, the current language, the identified issue in that section, the suggested language or modification, and the source of each recommendation. This will enable us to understand your system's thought process and to see improvements that your tool can bring about. We've compiled a list of resources to help you on this journey, and this includes military handbooks, NASA standards, NESC technical bulletins, NASA lessons learned, and NASA technical reports. Feel free to explore these, but remember, they're starting points, not limitations, and you're not bound to use all of these. It's up to you, really. As for scoring, we're looking for solutions that provide clear benefits and justifications, that simplify the process of filtering recommendations, and that ensure a user-friendly experience. Top-notch solutions will incorporate security measures to safely process sensitive information. To submit your solution, provide the source code or a description of your process for your app, along with a brief report explaining your approach and methodology. We can't wait to see your innovative solutions. Together, let's revolutionize the aerospace industry. Good luck, innovators. Let the STAR Challenge begin. Remember, the future of space exploration could be in your hands, so give it your all and take it seriously. Failure, it's not an option.
Once everything's perfectly organized, I'll start working on my thesis.
Grammarly will ensure
Hello, participants in the 2023 International Space Apps Challenge. I'm Daniel O'Neill. A few of you may know me as Dr. Dano. I'm a civil servant in the Office of Strategic Analysis and Communications at Marshall Space Flight Center. This year, we have a wide variety of exciting challenges. I hope that you and your team will consider the Visualize a Space Mission Using Virtual Reality challenge. Imagine an Earth orbiting satellite or an Earth to Moon mission that requires an orbital transfer maneuver, or a spacecraft in a cyclical orbit around Earth and Mars, or a deep space probe as it traverses the asteroid belt. The objective of this challenge is to create an interactive 3D model embedded in a web page. The 3D model can present an orbital trajectory and a spacecraft. Controls for the model can animate the movement of the spacecraft along the trajectory. If you accept this challenge, you will gain hands-on experience in developing a web-based virtual reality model using free open source resources and deploying it on a web hosting service. Check out the resources of the challenge. There are links to tutorials and demonstrations. I'll present a few of them. This is an example of one of the resources. It's a web page, and it's got a multi-part demonstration and all associated tutorials. The tutorials provide a brief overview of NASA's General Mission Analysis tool and show how that it can be used to generate time series data of X, Y, Z, or Cartesian coordinates to generate a trajectory. As just a brief example, here is an object moving around the Earth, and it's doing a Hohmann transfer. And you can see that you can interact with the model and zoom in and out. And this is the tutorial that goes along with that. So it provides some step-by-step procedures and code examples. Here's another example of an interactive web app. It presents trajectories of potentially hazardous asteroids. And so you can see the trajectories. It's got labels for the asteroids. This one was implemented as JavaScript, as are the tutorial demonstrations. There's another web page, and it's a tutorial on how to implement an elliptical orbit, and it goes through and step by step and provides code examples written in the R programming language. And it's got interactive 3D models on how to rotate the orbital trajectory using the various Keplerian parameters. And then here's some code for to propagate an object along the trajectory. And here's an example of some animation, of a model that's embedded in a web page with some controls. So I'm looking forward to all of the great web apps that teams will be developing this year. Happy coding.
Navigating IT certification prep was tough until exam topics. Ever wondered how some professionals effortlessly
Hey there, I'm Elizabeth Joyner, Community Coordinator of NASA's Earth Science Data Systems, and I'm also a geologist. Today I'm out here collecting data, but I can't always seem to collect the data that I need. This is a frequent problem for geologists around the world. Earth's environments are not always accessible. But hey, wait. NASA has a big collection of data that can help world's geologists. Maybe you can help us. Welcome to the 2023 Be a Space Geologist Space Apps Challenge. Your challenge is to use NASA's Earth observing data to create an app for geologists and use your imagination to show us that geology doesn't always require field work. Good luck.
Hi, I'm Sarah Lupton, the Science Data Operations Manager for NASA's Earth Science Data Information System, or ESDIS, and a co-author on this challenge. I currently help manage our 12 data archives, or DACs, but before coming to NASA, I was a geologist. I love geology because it's relevant to everything on Earth. Almost everything you can think of somehow relates to geology. Are you interested in gaming? LCD screens are made out of minerals, including quartz, galena, hematite, anglesite, spherulite, and more. Do you like to garden? Geology affects how soil is distributed on the Earth and how fertile it is. Interested in helping people affected by disasters? Earthquakes, volcanoes, floods, and landslides are all studied by geologists. This challenge gives you a chance to use NASA's Earth data to find out how your interests connect to the planet we live on.
Hi, I'm Danielle Golan, the Remote Sensing User Services Lead for NASA's Land Processes Distributed Active Archive Center, or LPDAC, and a co-author on this challenge. Now, why is this challenge relevant to today's world? Well, geology is all around us. It's in the landscape you're looking at, the mountains you hike, the dust particles in the air we breathe. It creates the materials used to build our homes or parts of our phones, and it's even in our food. And previously, geology had to be conducted in the field and in labs with specific equipment. But today, thanks to the vast amount of no-cost remote sensing and geospatial data, like that from NASA's LPDAC and the other DACs, anyone can easily access this data to do things like monitor volcanoes and other natural hazards, to map minerals, or to study other geological processes on the Earth, all from the comfort of your own couch. We need remote sensing-based geological tools to help us in our daily lives, and that's where you come in.
Hi, I'm Jennifer Brennan, ESDIS Communications Lead and a co-author on this challenge. Maybe you are still trying to determine your challenge. So why this challenge? Because geology is important in our everyday lives. When you think about resiliency, you know that our ability to be resilient through natural disasters such as earthquakes, landslides, floods, and volcanic eruptions is greatly improved by our ability to predict their occurrence. Geology plays a major role in this. Not only is geology used to study seismic activity and tectonic movement, but also it is critical to the process of planning for and engineering safe structures and in looking at our changing planet. Your challenge is to design an app that uses NASA Earth observation data for geologists. The app must use NASA's Earth observation data, but how you use it is truly up to you. If you're stuck for ideas, think about your own geological interests. With your help, we can broaden participation in geology, increase accessibility to knowledge, and embrace new technologies that can respond to changes on our planet, all in support of open science. Now, don't forget to check out our resources to help you get started with NASA Earth Science data. We can't wait to see what you develop.
Today, I'm doing the Rexona Gray T-shirt challenge. Rexona or your other deodorant. Let's put them now in a test. With
Welcome. Hi, my name is Adam Wilson, and I'm a lead scientist on the NASA Biodiversity Survey of the Cape. I'm also one of the authors of the Explore a Biodiversity Hotspot with Imaging Spectroscopy Space Apps Challenge. I'm so glad that you're interested in this project. I'm here in the greater Cape Floristic region of South Africa. This area has 9,000 plant species, 2/3 of which exist nowhere else on the planet. And not too far behind me is the southern tip of the African continent. This is where the Atlantic and Indian Oceans meet. This area is teeming with life, but it's also under threat. This area is facing growing human population, habitat destruction, invasive species, changing wildfire regimes, and climate change. We need to do a better job at managing our ecosystems so that they can continue to maintain and provide the goods and services that we rely on. NASA is making incredible strides to building technology that can dramatically enhance our ability to monitor ecosystems from above. But we need your help.
We want you to help us use remote sensing data to study biodiversity in the greater Cape Floristic region. Remote sensing data comes from instruments attached to satellites and other aircraft that pick up on different wavelengths of light. This helps us look at dust cover, land cover changes, surface temperature, distributions of terrestrial and marine species, and more. When combined with field data, this gives us a unique view of the planet. Here's what you can do.
For this challenge, you have access to a profusion of resources to help get you started. Use the EMET sensor or other publicly available data to map biodiversity in the Cape Floristic region. You may also search key phrases such as biodiversity data sets or a naturalist. As for what to do with the data, you could map terrestrial and marine habitats, delineate species distribution, or even create a visual or other media of storytelling. The options are truly endless. Your contribution could come as a summary on a web page, a coding notebook that displays maps and images, or simply a render of your artistic work. The mission is yours for the taking. Will you answer the call?
Hi, this is Karen and Elodie from the NISAR applications team from NASA, and we invite you to create a work of SART, aka Synthetic Aperture Radar Art. Your challenge, should you choose to accept it, is to submit an original piece of SART work that helps to highlight what radar imagery is capable of. We will be using synthetic aperture radar, or SAR data, in preparation for an exciting new mission called NISAR, set to launch in early 2024 from NASA and ISRO, the Indian Space Agency. This is a unique opportunity to be involved in promoting all that NISAR will be able to do in the coming years. Step 1 is to review the list of recommended data sources from this challenge and download SAR data from a region of your choice. Step 2 is to let your imagination run wild. Create any form of digital art. It could be an image, 3D model, music, the sky's the limit, which can also be said for our radar instruments. And step 3 is to submit your SART work on a public domain for a chance to be one of the final Space Apps Challenge winners. For a bit of inspiration, let's take a look at this animation of how NISAR will use synthetic aperture radar to create high spatial resolution images of the Earth's surface. And now, here are some examples to spark your creativity. These are postcards downloaded from NASA's Airborne Radar UAV SAR using pulsar imagery to highlight different radar polarizations, or channels. This allows you to highlight different features on the ground, such as open water, roads, and vegetation. And here's another example of a 3D model video. The visualization shows over 10 years of deformation on the Hawaii Big Island and also captures activity from the Kilauea volcano, which erupted in June 2018. Now, passing the mic over to Elodie for a few more examples.
This challenge is not only a chance for you and your team to showcase its artistic talents, but also a wonderful opportunity to educate your community on how the science of SAR data can be helpful to them. An amazing capability of SAR is that it can be used to observe natural disasters and their impacts, regardless of cloud cover. For example, here, SAR data was used for the detection of flooded areas in Bangladesh. It can also be used to monitor activity like the growth of a new lava dome inside a crater and where the volcanic flows and ash were spread out during the eruption. This is all done looking at time series of the intensity of the SAR signal to detect surface changes. Another example here is to look at the inflation and deflation of a volcano, which is caused by the movements of the magma underneath and inside it. This can help people understand when an eruption might be coming. And to measure the vertical displacements at the surface, the technique of SAR interferometry is being used. It looks at the differences in the phase of the radar waves returning to the satellite between two SAR images. The destruction caused by an earthquake can be catastrophic, and SAR data can help find the damaged buildings before the dust settles. It looks at the points of similarities between SAR images captured before and after the earthquake. This is called SAR coherence, and in this case, the loss of coherence indicates that a building has been damaged. But SAR isn't just useful for natural disasters. It can also help communities better understand and manage their resources. For example, SAR data can help farmers improve their crop yield by looking at ground properties like soil moisture. It can even help monitor groundwater reservoirs by looking at surface movements like here in the basin of Los Angeles in California. Your work of SAR will help to highlight the wide range of applications for SAR data, and by posting it onto an open source channel, you have a chance to share your knowledge and help educate the general public on the benefits of SAR. And with the upcoming launch of the NISAR mission in early 2024, your work will be more relevant than ever, and you could possibly even be showcased during this historic event. We can't wait to see what you will create. Good luck, and more importantly, have fun.
Companies of all sizes use BigQuery to uncover new insights from their data, like cost savings, operational efficiency.
Hi, my name is Paige Martin from NASA's Chief Science Data Office at NASA headquarters, and I am leading the challenge called Open Science Storytelling. Open science is a movement sweeping across the globe with inclusive and accessible values at its core. Tell a tale of sharing data or of an open source space probe. We seek stories of openness with creativity galore. NASA is all about open science, making our science more accessible, reproducible, and inclusive. By open science, we are referring to the opening up of our scientific workflows by sharing our data, code, methods, and results. NASA is looking ahead at really big challenges where we need more eyes, more hands, more brains from diverse backgrounds and experiences to make sure that we are asking the right questions and getting the best possible solutions. By adopting open science practices, we can accelerate the pace of science so that we can keep up with society's biggest challenges, and we can make sure that everyone who wants to is able to participate in our scientific community. At NASA, I work with incredible teams in both the Transform to Open Science, or TOPS, initiative, as well as the Open Source Science Initiative to help support and enable open science. Plus, did you know that this year, 2023 is a year of open science, the United States White House declared this year to be the first year of open science, and currently there are 15 US government agencies that have joined. Pretty amazing. In this challenge, we want you to tell an open science success story in a creative way, using any form of storytelling, from singing to poetry to dance to puppetry to acrobatics and beyond. Your story can be any aspect of open science. By sharing our success stories with one another, we can showcase the wonderful open science work underway in the global community and provide real-world examples of successful ways to integrate open science into our scientific workflows. So, if the poem that I mentioned at the beginning of this video didn't inspire you, maybe a song will. Just 2 words that I heard someone say. I need those words to help me find my way. Whoa, open science. What a great idea. My, how could I resist you? Open science. You have me in your thrall. Open science is for all. Yes, I was sad and lonely until I found this community. My, I will never look back now. Hey, space apps, by now you all should know. Open science is the way to go.
We gotta streamline these ideas. We need Grammarly.
I've got your back.
Hello, Space Apps Challengers. I'm Dr. J.L. Galache. I'm a support scientist at NASA's Chief Science Data Office. Here at the Chief Science Data Office, my colleagues and I are working on NASA's open source science initiative. NASA's scientific data is already open and has been used in many Space Apps challenges. But with this initiative, NASA wants to make it even more open, more accessible, more easy to find, easy to work with. Also, the software that researchers use will be made open and available. And also the publications that come out of this research will also be made open. And I'm talking to you today from beautiful Colorado. I'm in the foothills of the Rockies in one of Boulder's open spaces. And they're not just open because they are out in the open. They are open spaces because they are open to everyone. And this ties in nicely with our challenge this year, which is a marketplace for open science projects. I know, it's 2023. We should be able to figure out how to find like-minded people to collaborate with. And this is where you come in, dear challenger. We want you to join this challenge and enable open scientists to find each other, to come together, to work on exciting open science projects. And now I'm going to pass it on to Nick, who will explain what this challenge is all about.
Hello, Space Apps Challengers. My name is Nick Halper, and I'm the CEO of NeuroMatch and Climate Match. Climate Match is a NASA-funded global educational program focused on computational tools for climate science. Our organization works on global collaboration at scale, so we're excited to see how you handle these challenging problems we're throwing at you. There are many different open science projects and open source tools around the world, but there's no solution for easily matching project creators and skilled contributors that want to work on those projects. Your goal is to create a solution that will help efficiently match these two groups so that they can find each other and find projects that are best fit and help them communicate so that they can easily work together. Now, a challenge like this might seem easy, but when we think about all of the existing solutions like tags or drop-down menus, they're not very efficient and they don't scale very well. So any solution that can handle the sort of like complex and messy data that exists in this sort of ecosystem is going to be very powerful. This challenge may seem simple from the outset, but solving this problem could bring a whole new generation of open source projects and tools to life. So we're excited to see how you handle it.
Welcome. My name is Sydney Neugebauer, and I work at NASA's Capacity Building Program, part of the Earth Science Division. I'm the challenge author for the NASA in Your Neighborhood Challenge. So you probably already know that NASA's science helps us explore our solar system and beyond, but did you know that NASA also studies life right here on Earth? In fact, you can learn a lot about your own neighborhood using information from NASA's satellites, which orbit the globe every day. We can learn about all kinds of topics, including air quality, water quality, tree canopy, and even urban heat from the vantage point of space. This information is even more powerful when you combine it with information about people living on the ground. So, in this challenge, we're asking you to look around your own neighborhood or town and ask a question about how the people that live there interact with the environment. We would like you to research that connection and then share the information back to us in a creative way. You probably already know a lot about what makes your home unique, including the natural environment and the people that live there. But that means that you're uniquely positioned as a scientist to ask a question about the world around you and then use data to answer that question. Maybe you want to know how wildfire smoke impacts different neighborhoods. Or is the water quality in a local lake worse after a rainstorm? And who might need to know that information? Once you've asked a question, you can try to answer that question using information from NASA satellites and data about the people living there. There will be a lot of data to explore, but that is where your NASA subject matter experts come in. And then finally, to communicate this work, you will develop a creative communication product. This can be a local news report, a poster, or a short video, whatever you think is the best way to share what you've learned. We hope you'll join us in exploring your own neighborhood from the vantage point of space and experience firsthand how NASA sees the world without being an astronaut.
If you want to make money online as an affiliate marketer, you may find this a little bit controversial, but we've stumbled across a way to earn reliable.
Welcome. I am Lauren Sanders, the acting project scientist for the NASA Open Science Data Repository and a staff scientist with Blue Marble Space. And I'm a challenge author for the Space Biology Digital Twins Mechanistic Mathematical Models for Standard Reference Organisms Challenge. I'm thrilled to introduce you to an exciting challenge that holds the potential to transform our understanding of space biology. In the vast realm of deep space exploration, we're confronted with a unique question. How do living organisms adapt and thrive in the extreme conditions beyond our home planet? I want you to envision a world where we can simulate and predict the impact of factors like radiation and altered gravity on living beings in space. This is where the Space Biology Digital Twins Challenge comes into play. The heart of this challenge lies in the development of digital twins, computational models that mimic real-life organisms. These digital twins will allow us to simulate how organisms respond to different stressors, essentially predicting their behavior in space. Now let's talk about the star of our challenge, C. elegans. It's a small worm that has been a key player in NASA's space experiments. Its unique attributes make it a prime candidate for us to unravel the mysteries of space adaptation. But here's where you come in. We're building upon the foundation of an open source project known as Open Worm, and we're inviting you to join this mission. We're looking for your creativity, your expertise, and your passion to help design what will ultimately become an open source project that will enable a global community to contribute to the creation of a comprehensive C. elegans digital twin. Imagine having a virtual C. elegans at your fingertips, a tool that empowers us to predict how various challenges in space affect life on a fundamental level. By harnessing the power of digital twins, we're poised to unlock insights that were once hidden from us. Our understanding of space biology is on the verge of a groundbreaking leap forward. So whether you're a coder, a biologist, a space enthusiast, or simply someone who's eager to make a difference, this challenge offers an extraordinary opportunity for you to contribute to the future of space exploration. So I'd like to invite you to be part of the Space Biology Digital Twins Challenge. Let's come together and pioneer a new frontier in space exploration, one digital twin at a time.
Exam Topics is the go-to source for thousands of people looking to get IT certified fast and guaranteed. You ask me why?
Welcome. I'm Lauren Sanders, the acting project scientist for the NASA Open Science Data Repository and a staff scientist with Blue Marble Space, and I'm a challenge author for the Building the Space Biology Model Zoo challenge. I'm excited to introduce you to a cutting-edge challenge that's at the intersection of space exploration and the power of machine learning. It's a venture that has the potential to transform our understanding of space biology. Imagine a scenario where we can leverage the capabilities of machine learning to decode the intricate relationships within biomedical and space biology datasets. This is where the Space Biology Model Zoo challenge comes into play. The challenge revolves around empowering a powerful machine learning technique known as transfer learning. This technique allows us to pre-train a model on a vast and diverse dataset, capturing the underlying features and insights. Then we fine-tune this model using a smaller dataset tailored to a specific problem, in this case, the unique challenges of space biology. In the realm of space biology research, we often encounter limitations in space and sample size and confined problem space. That's where transfer learning can become a game changer. So here's your mission. We're calling on you to design an extensive database that gathers publicly available biomedical datasets. These datasets will then serve as the foundation for creating a model zoo, a collection of pre-trained models that encapsulate knowledge from diverse domains. But that's not all. The second part of this challenge focuses on identifying relevant space biology datasets that can be used to fine-tune these models. This process will enable us to dig deep into specific space biology questions. Think of it as unleashing the power of machine learning to amplify our exploration of the cosmos and the mysteries of life beyond our planet. So, whether you're a data scientist, a biologist, a machine learning enthusiast, or someone who's curious about the cosmos, this challenge offers a unique opportunity to contribute to a paradigm shift in space biology research. Join us in the Space Biology Model Zoo Challenge, and let's harness the power of machine learning to unravel the secrets of space biology.
Hi, I'm Dominic Benford, and I'm an astrophysicist at NASA. We invite you to join us in an exciting trend in creating sonifications of NASA science data in 3 dimensions.
Hi, I'm Liz Landau, Senior Communications Specialist at NASA headquarters in Washington, and I'm a subject matter expert for the challenge Immersed in the Sounds of Space. So in this challenge, we're not talking literally about how space sounds. We're talking about translating all of this light, all of this data into an experience that we can listen to. Let me play you an example. What you just heard is the sound of a black hole. And again, it's not literally how the black hole would sound if you were nearby, but my very talented colleagues came up with a way to take data about the pressure waves coming from this black hole and scaling that up to human hearing so that we can actually listen to it. It does sound kind of creepy. There are a lot of cosmic objects out there, and there are also some amazing 3D fly-through videos that we have here at NASA. Do you have ideas about turning those into sound experiences? What we call these translations of data into sound is sonification. And we have a whole library of sonifications that you can listen to for inspiration. Here's the Carina Nebula from the James Webb Space Telescope translated into sound. So that was a very different approach from the black hole. This was a more musical experience. Do you think that these 3D fly-through animations would be more musical, more sci-fi, more weird? We're really interested in your ideas. How would you go about mapping what you see into what you can hear? Sonifications aren't just fun to listen to. They're also really important, especially for the community of blind and visually impaired individuals. This is an amazing way to access the universe if you can't look at the NASA space images.
Sophisticated new instruments have been used to create multicolored images of Earth and objects in space. Instead of having the usual red, green, blue images, we might have 10 different colors, or even 100 different colors. These are called multispectral or hyperspectral images. Can you think of a way to use sonification to allow people to hear what our eyes cannot see?
So we're really excited about this challenge, and we hope that you are as well. Good luck and have fun.
Hello there. Have you ever wondered what it would be like to visit another world? Imagine if you could visit one of the other planets, moons, or even an asteroid in the solar system. Which one would you choose to go to? What if you could climb to the top of Olympus Mons on Mars, the highest mountain in the solar system, or paddle serenely across the still methane lakes of Saturn's moon Titan in a canoe, or even ice skate across the frozen surface of one of the moons like Europa or Triton? How would you get there, and where would you stay? Would you take a space cruise liner that would whisk you across the solar system to your destination? And would there be an orbiting space hotel, or perhaps a domed surface habitat where you could stay in, complete with space-themed menus and entertainment options? Well, sadly, we can't book such a tour, not just yet. But nothing's to stop us from taking a trip in our imagination. This NASA Space Apps 2023 challenge is to create a virtual planetary tourism office that will provide a customized one-week guide for different worlds in the solar system. Now, you may choose to build a fancy interactive website where holidaymakers can choose their destination and get a customized itinerary for their destination, complete with imaginary transportation, entertainment, and the hotel options. Or you may decide to do something simpler and produce some standardized brochures for the main attractions of the solar system. Each guide should include a map of some important sites that could be visited along the way, along with information such as when did this volcano form? What causes the red color in these rocks? Or even, is the air breathable? It's up to you and your imagination to have fun. But most importantly, since this is NASA, we would like your guide to be as scientifically accurate and educational as possible. You will be judged on the scientific and technical merits as well as your creativity. So go wild with your space tourism office and let the worlds of the solar system fire up your imagination. Good luck.
Hi, Space Apps. My name is Cynthia Hall, and I'm a support scientist for NASA's Early Career Research Program in Earth Science. Today, I'm coming to you from our Earth Information Center at NASA headquarters. The EIC, as you can see, is an incredible display of NASA data that are used in monitoring climate change, which can inform critical decision-making.
Have you seen the news lately? Extreme events across the globe, droughts impacting agriculture and water resources, higher than normal sea surface temperatures causing coral bleaching and possibly more intense cyclonic storms, wildfires impacting ecosystems and air quality, and flooding causing devastation of numerous cities around the world. It is time to bring together the plethora of open data available through U.S. federal agencies to combat these climate-related challenges for societal benefit.
The collective challenges we face as a civilization demand that we change science now so that we have the successful, efficient, inclusive scientific ecosystem we need to improve our ability to respond to challenges. This means we need more open, cross-disciplinary, collaborative science. Open science, as defined by NASA and other federal agencies, is the principle and practice of making research products and processes available to all, while respecting diverse cultures, maintaining security and privacy, and fostering collaborations, reproducibility, and equity. In January 2023, the White House designated 2023 as a year of open science, featuring actions across the federal government agencies to advance national open science policy, provide access to the results of the nation's taxpayer-supported research, accelerate discovery and innovation, promote public trust, and drive more equitable outcomes.
Hi, I'm Sudhir Shrestha. I'm in the challenge Mapping Data for Societal Benefit. We ask that you design an open data platform that will allow users to explore most of the data that is available across different federal archives and develop a prototype for an area of study that has large societal benefits. For example, environmental justice, ecological conservation, or human health. The many agencies of the US government have substantial archives of high quality, freely available data, but they can be challenging to navigate. Datasets are in a wide variety of formats at different spatial and temporal resolutions, and so incorporating data from different sources can be complex and challenging. There are several existing platforms that provide access to the datasets. Many of these platforms provide lists of all published datasets or collate the data thematically. So we ask, can the functionality of these platforms be made more accessible and useful for interdisciplinary research with societal benefits? Can a new open data platform be designed to allow for cross-agency research and collaborations? Thank you.
We are so excited about this challenge because not only does it address challenges confronting us as one Earth, but also truly encourages making science more transparent, collaborative, and inclusive, which is going to increase trust in science, something we need. Lady Bird Johnson said, "The environment is where we all meet. We all have a mutual interest. It is the one thing all of us share." Let's come together, bringing our diverse experiences, perspectives, and expertise, and solve these challenges. Join us in mapping data for societal benefit.
Bayeux, real homes live here.
Hello, I'm Manil Maskey, a senior research scientist from NASA Impact Project at Marshall Space Flight Center, and also the artificial intelligence lead at the NASA Science Mission Directorate at NASA headquarters. I am a challenge co-author for GeoAI Reimagined, Transformative and Diverse Earth Science Applications Using Foundation Models. This challenge features a first-of-its-kind geospatial foundation model, a result of collaboration between NASA and IBM Research. The best part, we have made this model open source through Hugging Face, making it freely available to all. I invite each one of you to join us in this challenge, where we embrace the spirit of collaboration, innovation, exploration, and inclusion, all aligned with the NASA's Year of Open Science. To guide you on this challenge, next, our colleagues at IBM Research will provide comprehensive details on Foundation Model itself and help you unlock its potential. I wish you all happy hacking and good luck.
Hi, Space Apps. My name is Lin Song, and I am a senior technical staff member at IBM Research based in Yorktown Heights, New York. So in the past few months, I'm pretty sure all of us heard a lot about generative AI and foundation models, especially in the language domain where foundation models are really changing many people's daily lives by making their daily tasks more productive. So in the past year, one question we've been asking ourselves is, what if we can apply the same idea, the same foundation model concept to geospatial science, such as Earth observation data? This is particularly important for two reasons. Up until now, there haven't been many models out there that one could just take off the shelf and customize or fine-tune to their specific applications in earth science. Well, there are big models available out there in related domains like computer visions, but Earth observation data like remote sensing data are more complex. Its multispectral nature makes the learning not transferred well from models trained with only RGB. And its temporal properties like seasonalities are not captured in static image modelings. Second, one of the biggest challenges about Earth science data is that the volume of data is so huge, but the amount of label data is so small, because labeling such kind of data is a very time-consuming and error-prone process. We believe foundation model is the perfect fit for this kind of data challenge, as foundation model is about training a huge self-learned model from unlabeled data, which can easily be fine-tuned to different downstream applications using very small amount of application-specific data, which massively decrease the amount of data labeling required and ultimately increasing productivity and impact. For this reason, NASA and IBM Research partnered up to create a first-of-its-kind geospatial foundation model using harmonized Landsat Sentinel data from NASA. This model, which is available now on the open-source AI platform Hugging Face, will be at the center of this Space App Challenge, as we ask participants to leverage it to explore new downstream applications in areas like disaster response, environmental change monitoring, and more. Now, my colleague Daniela from our Brazil Research Lab and Paulo from our UK Research Lab will use our IBM NASA Hugging Face page to walk you through the details of the science behind the model and the tools that we provide to get started with the challenge.
Hi, my name is Daniela, and I'm a research scientist at IBM Research in Brazil. So, foundation models are large machine learning models trained with big data sets, such that with only a few adaptations, they can be applied to a wide range of downstream tasks. Let me show you how we implemented and trained our foundation models on the harmonized Landsat Sentinel data from NASA. Similar to what is done for text and natural images, we need a self-supervised approach to train the model, and data reconstruction is a straightforward task to accomplish this. It works like this. We take an input image, divide it into patches, mask some of these patches, and we train the model to reconstruct the original images. So the target is exactly the original image. The model actually has two parts, an encoder and a decoder. The encoder receives the image patches and extracts features from it. The decoder then receives those features and reconstructs the original image. If we train the model like this with a lot of data, the encoder becomes really good at extracting relevant features. And this is what we leverage when using the model for a downstream application. Once training is done, we can replace the decoder with any suitable set of layers for a specific downstream task and fine-tune the model for that task. Regarding our model architecture, it considers the multispectral and temporal aspects of remote sensing data. So our foundation model was actually trained on sequences of HLS images with RGB and infrared bands. You can access the model card on Hugging Face to see more details on our foundation model and download the model checkpoints. This can be done from the web UI or using the Hugging Face Hub library. Now, I'll pass over to Paulo so he can explain how our foundation models can be used for the challenge to target different downstream applications.
Hi, I'm Paolo Fraccaro. I'm a research scientist at IBM Research UK. And as Daniela said, I'm going to give you a little bit more details on how to use the Geospatial Foundation model for the Space Apps Challenge. Let's dive in. On the IBM NASA organization card on Hugging Face, in addition to the geospatial foundational model that you can find here, as Daniela has shown, we have a number of examples of fine-tuned models to specific downstream tasks. They include, for example, flood detection, multi-temporal crop detection, and burn scar detection. And you can really take these and the related data sets as an inspiration for the challenge. So they can be used, adapted, but they can also be an inspiration, and you can bring in your own data and applications. So to understand a little bit better what happens when the geospatial foundational model is used for fine-tuning and to a specific downstream task, let's dive in on one of these models. Let's take, for example, the crop classification one. All the details about the model, performance, and other details are here, but I would like for a second just to focus on this image. So to fine-tune the model, what we need is new input images. In this case is HLS data, multi-temporal HLS data, and some labels of an application of interest. In this case is a crop classification. So what happens is that we are going to reuse the encoder of the geospatial foundational model, combine it with the coding head. There can be different ones. In this case is a convolutional head. And using these new labels, the CDL labels in this case, we're going to fine-tune, to train with some sort of loss to customize to our specific application. And in this case, we are providing 3 timestamps as it was originally done for the pre-trained model, for the geospatial foundational model, and we're using HLS. But if you go through the other models, you'll see that the model can be adapted for any other number of timestamps as both flood detection and burn scars detections. Just use one timestamp, but also different resolutions, because, for example, flood detection uses Sentinel-2 data, which has a 10 meters resolution against the 30 meters resolution of HLS. So having understood what happens, let's see in the model in action with a demo example. Each of these models have a demo page that you can use, dropping your own images, or there are also some images here for people to play. So you see now we have 3 different timestamps that are provided to the model, and in this case is 3 different growing seasons for the crop. And this is the sort of output that you're gonna get. And you have a number of crop categories here alongside, for example, open water and others. Now, another thing that we provide that you can leverage to do the task is the code, sample code that we have used as part of the IBM NASA collaboration. This is a simplified version of what we're using, but it allows you to do everything you need for the Space App Challenge. So in this GitHub repo, you have all the details to set up your environment and to leverage the code, how to use it. And the only thing that you need to do is to get new data, new labels. You can reuse the ones that we have shown you. But in addition to that, we're leveraging segmentation as the library that we have used to fine-tune our models, and is adapting or reusing one of these config files. You have the ones that, for the examples that we have shared on Hugging Face, and they contain all the information about your training, about your data, and I'm not going to go into much detail here, but you can have a look, and all the MMSAG documentation applies, so you can get more familiar with how it works through the original documentation. Once you have your config file customized for your application, then here there are simple instructions on how to leverage it to complete your task. Just train segmentation, and this is going to follow the instructions that are specified in your config file. So you have all the details about the models, you have all the details about the code, and you'll be able to deploy it on your favorite environment, IBM Cloud or others. And this is all from us. I wish you best of luck.
Deliver the right content at the right time to the right audience.
Hello and welcome to our Space Apps Challenge 2023 on magnetic reconnection and space weather effects. I'm Dr. Abigail Reimer, and together with my colleagues Dr. Isaias Shumay and Janine Fisher, we'll be working with you to explore the access of the Earth's magnetosphere, of the solar wind to the Earth's magnetosphere. So that's the fiery thing you see coming from the side, and there's a plasma injection going off, and these are the Earth's magnetic field lines, and that's creating the aurora on the Earth, and what you might be familiar with as the Earth's northern lights. And what we want to explore is using the many decades of NASA data in the solar wind to see if there's a correlation between solar season, solar wind type, Earth season, or anything else that will provide insight into what are the solar wind conditions that most easily can access the Earth's magnetosphere. So we thought this was a great activity for data mining, and we have a lot of data. And in particular, we're going to focus on 3 spacecraft which are at the Lagrange 1 point, so upstream of the Earth, sort of roughly co-located with each other. They've been there for the wind since 1994. ACE has been there since 1997, and the most recent one is Discover, which was launched in 2015. There's a link here which is available to you in the material circulated as part of the Space Apps Challenge that will take you to the OmniWeb Data Center, which anyone with a PhD in plasma physics is very aware of, and most of us have cut our teeth on at some point in our careers. So we'll be here to help guide you as you gather that data set. So as well as gathering all the data together and getting to have a deeper appreciation for the NASA data sets and the amount of information that we have available to us, at the end of this challenge you will have a deeper appreciation for how our star expands into space. So here's a view that was created by the New Horizons team. So here's the planet Pluto out to the side here, and Earth is buried in the middle somewhere here. And you can see in this plane the solar wind is expanding in this spiral shape. And I'm quite excited to share with you some more of the deep understanding that we have of our solar system as a result of all of this amazing data that NASA's been taking for the last several decades. So I'm very excited to see what our global community come up with, and to meeting you all. I'm sure that you are going to be equal to the task, and it's going to be a very exciting challenge. So have at it. Thank you very much.
Astronomy, a wonder, a myth, or magic? So many questions, and it. How do they see? Or how do they feel? Today we will reveal the answers through gameplay. We from the team Nebula Nexus present you our game Astronaut. Let's start our journey. Our game is divided into multiple levels. In the first level, we'll learn about physical fitness. Watch this picture. It illustrates the difference between
Hello, everybody. Thanks for joining us today. I just want to remind you that our deadline for ITO submission is today at midnight. You will receive the judging slots by email. Our judging panel will be tomorrow at 4 p.m. You can join Space Connect through GitHub if you have any questions, general question or technical question or questions about your idea submission, or you can reach us through our emails. Thanks for joining us. Thanks for joining NASA Space Apps Challenge 2023 UAE and Muscat. Thank you.